Hey guys. All right, any questions about the homework? Any questions? No? Okay. So if you want me to go over any of them, feel free to ask me in the chat so I can explain that for you. So if you just came in, if you have any questions about the homework and you would like me to explain any one of the problems, then you can chat that problem to me and I'll explain it for you. All right, so we're gonna wait here for another 2 more minutes until we start. All right, so if you just came in, if you have questions about homework, chat that question to me so I can explain it for you. Let's see here. I'll share my screen. All right, I'll wait for just a few more moments. Someone's immediately started to draw on the screen. Didn't even have time to disable that. All right, so I'm just gonna wait here just a little more for people to trickle in. All right, I'm just gonna get started now. So this week, we're gonna be talking about angles, all right? So topics are, what are angles? So we're gonna talk about like what they are. And then we're gonna talk about special angles and words we use to describe those angles. And then we're gonna talk about two special cases for angles. First, angles in parallel lines, and then angles in polygons. Okay, so what are angles? Let me just say, what if I just drew two lines? All right, as you can see here, there's space between these two lines, right? And the space between this line, that's what we call the angle. So an angle is basically the space between two lines. It's like a crocodile mouth. Okay, so we define the angle as the space between these two lines. If the angle is small, then the space is small. This is a small angle. If the angle is big, then the space between the lines is also big. All right. So how do we measure angles? For angles, as you can see here, if I draw this line, we can have a small angle like this, an angle like this, an angle like this, or we can have an angle all the way like this so that the angle goes around like a circle. If we go all the way around the circle until we get to back where we were, this is called a 360 degree angle. So we define angles in degrees. So for one whole circle, that is 360 degrees of angle. All right. So what does that mean? If we have half of a circle, a straight line like this, that's 360 times 1/2, right? Because we have half of a circle. Half of 360 is 180 degrees. All right. So what do we call this angle? We call this angle a straight angle. All right. Whenever we say, oh, there's a straight angle in this problem, we're going to be talking about a 180 degree angle. Okay. That's because it's a straight line. That won't be too hard to remember. And then we have another special type. If it's only 1/4 of a circle, we call this a right angle. And since a right angle is 1/4 of a circle, that's 1/4 of 360 degrees, which is 90 degrees. And instead of writing a curved symbol for a right angle, we write a kind of like a box. So it makes a square here, right? So a right angle is 90 degrees. So two important angles you guys should remember are right angles, 90 degrees, and straight angles, 20 degrees. Okay? All right. So let's talk about some special angles and words we use to describe angles. So we already have two types of angles here, right angle and straight angle. We have other words to describe angles. If the angle is smaller than a right angle, this angle is called an acute angle because it's small and it's acute. If the angle is between a straight angle and a right angle, like this, we call this obtuse. If it's greater than the straight angle, and the angle goes all the way around like this, we call this a reflex angle. Okay, so those are words we use to describe what angles are. And then we have some special kinds of angles. So when I draw two lines like this, I make four angles here. One angle here, one angle here, one angle here, and another angle here. 4 angles. All right, so as you can see here, these two small angles look like they're about the same value. And they are. These two small angles are the same magnitude. They have the same amount of wideness. All right. So when we cross two lines together, these two angles have the same measure, which means these two angles also have the same measure. And we call these angles vertical angles. So vertical angles don't mean that the angle is vertical. It just means that when we cross two lines together, they make pairs of vertical angles. Okay? And these angles equal each other. And the word we use to describe angles that are equal to each other, we use the word congruent. And we use the word congruent for shapes, lines, all that. So we're going to be using the word congruent a lot, which basically means that these two angles are equal to each other. So these are vertical angles. So whenever we cross two lines together, we have two small angles of congruent, and then two large angles that are also congruent. Okay? Finally, we have two other types of angles here. So we have what are called complementary angles. What are complementary angles? Well, let me give you an example here. Complementary angles are defined as when you add these angles together, they add up to 90 degrees. All right, so that means an angle of 30 degrees is complementary to an angle of 60 degrees. So complementary means adds up to 90 degrees. And another example is, 1 and 89. Those are complementary. 45 and 45. Those are complementary angles. Okay? And to define what a complement is, I might ask you, what's the complement of 30 degrees? What's the complement? That basically asks what other angle is complementary to this angle. Well, you would just do 90 minus 30 to get 60 degrees. Because these two angles have to add up to 90, so to get the complement of 30, you do 90 minus 30. And similarly, we have something called supplementary angles. Supplementary angles means the angles add up to 180 degrees. So this means 72 and 108. Those are supplementary. 90 and 90, supplementary. 1 and 179. Those are supplementary angles. All right, so as you can see here, 72 is the supplementary angle for 108. 90 and 90 are supplementary, and so on. Okay, so those are what we call supplementary angles. All right, so any questions about these? So let me give a little quick recap here. For an angle of 90 degrees, this is right. For an angle that is straight, 180. For an angle that is small, acute. For an angle that is big, obtuse. For an angle that goes all the way around like this, it's called reflex. And what else do we have? We have vertical angles. So vertical angles are defined as when we cross two lines together, these angles are vertical angles, and these angles are vertical angles. And vertical angles are congruent, which means they are equal in magnitude. And finally, we have complementary, which is add to 90. So I used the plus sign there, add to 90, and then supplementary, add to 180. All right. And if you want to take a screenshot of all that, feel free to do so. And I'll give you a second to screenshot that. All right. And we have one last thing we need to know. How do we describe an angle? Right? If we label this angle with 3 points, like this, how do we define this angle? How do we write this angle? How do we say, this angle is blah, blah, blah? Well, the way to describe an angle is to take one of these points on the ends and trace it along the angle. So we start at B, we trace along to the corner here, which we call the vertex. We get to A, and then we get to C, and we put a little angle symbol in front of it. So we call this angle BAC. We could have started that angle at point C as well. So if we traced it this way, this angle is also called CAB. But what this angle is not called, this angle is not ABC. All right, we don't start at the vertex. We name an angle by tracing it around like this. Okay, any questions? All right, let's do these problems here. So when you get your answer, please chat that to me. And I'll let you know if you're right. So for the first one, name the angle, which means write that in letters. Whoa, I'm getting a ton. Ton. So if I don't reply to yours, I think you should be okay. Oh, you guys are fast. Ooh, that's too much. You guys are doing pretty good on these. So if you got one of the questions correct and you would like to explain that to the whole class, you can let me know and I'll let you do that.
I think the answer for the bottom one is 85.
I think most people are done now.
Why?
So if you want to share your solution, please let me know. Chat that to me. And I'll let you do that. Oh, okay. So seeing that no one has volunteered, I'm just gonna go ahead and explain these for myself. All right. So for the first problem, we want to name the angle in the diagram. So we're gonna choose one of the endpoints. So let's just take B, and I'm gonna trace it around the angle. So we're going to go B to A to C. Another way to do it is from C to B. So C, A, B. So we trace it along the angle. Okay? For the second one, two angles are complementary and one angle has measured 28 degrees. What's the measure of the other angle? Well, if two angles are complementary, then they add up to 90 degrees. So the first angle is 28, second angle is X degrees, and they're going to add up to 90 degrees. So to get X by itself, let's just subtract 28 on both sides. X equals, let's do a quick subtraction there. 8, 10 to 62. So 62 degrees. Okay. Now for the last one, how do we solve for x? Well, as we see here, when these two angles are put together, they make a straight angle. They make 180 degrees. So if we add these two angles together, x plus 10 plus x, that's equal to 180 degrees. Okay? So combining x's, I have 2x plus 10 equals 180. Subtracting 10 on both sides, remember SADMAP, 2x equals 170. Now dividing by 2 to get rid of that 2, we get x to equal to 85. All right. So I see some people have raised their hands. Do you have a question? Okay. So let's do these problems now. So again, once you get your answer, please chat that to me, and I'll let you know if you're right. For the first problem, I see a lot of people are getting incorrect answers. So my hint for that one is to set up an equation. So when you set up an equation, that minimizes your chance of getting mistakes. So if you can't get the challenge problem, don't worry, because those are very hard problems. So try your best on those. If you can't, that's totally fine. So give you guys one more minute. right, I'm going to go over these problems now. So for the first problem, the measure of an angle is 16 degrees more than its supplement. What is the measure of the angle? Let's say that this angle is x. So what is x's supplement? X's supplement is 180 minus x, right? Because x plus its supplement will equal 180 degrees. So this angle x is 16 degrees more than its supplement. So that means x equals its supplement added to 16. So if we put x on the other side by adding x on both sides, we'll get 2x equals 196. We have to divide through by 2. And x is going to be 98 degrees. All right. So setting up an equation was really important and in doing this problem because it made it a lot easier as well. So now for the challenge problem, it's 4:30 on a clock. What's the angle between the minute and the hour hands? So a lot of people went, well, let me draw the tick marks here. So a lot of people went, oh, 4 o'clock, 30, that's 1/3. That's 1/3 of 180 degrees. Oh, 60 degrees. Well, that's not right because when it's 4:30, the hour hand doesn't stay at 4 o'clock. It goes halfway in between like that. Okay, so we have 1 notch plus 1/2 notch. And as you can see here, for 90 degrees, we have 3 notches. So that means this angle is 1/2 of 90 degrees. So the angle is actually 45 degrees. All right. So now for the other question, it works about the same way. So what if the time was 8:20? So let me draw out the notches again. I think that's right. 1, 2, 3, 11, 10, 9, 8, 7. All right, so 8:20 means that the hour hand is 1/3 of the way to 9 o'clock, right? It's 1/3 of the way between here. So 1/3. And now the minute hand is at 20. So how do we solve this one now? Well, a helpful thing to do is figure out how many degrees is 1 notch. How many degrees is between 12 o'clock and 1 o'clock? Well, there are 12 of these throughout the whole circle. So that means 360 over 12 is the degree measure of one of those notches. So 360 over 12 is 30 degrees. So one of the notches is 30 degrees. So we have 1, 2, 3, 4 notches plus 1/3 of a notch. So it's 4 times 30 degrees plus 1/3 times 30 degrees. So that's 120 plus 10, 130 degrees. Okay? So for these problems, you have to take into account the fact that the hour hand is also moving a little bit between the hour, between 8 and 9 o'clock in this instant. Okay, any questions? All right, now we got angles and parallel lines. So first of all, what are parallel lines? Parallel lines are lines that basically have the same slope. They're going at the same direction. So these two are parallel lines. These two lines are parallel lines. They're going in the same exact direction, and they're going to go on and on and on forever without ever crossing. So those are called parallel lines. And we label them either with these arrows on the lines, or if this was line A and this was line B, we say line A is parallel to B that way. All right? So those are what parallel lines are. Now, what about angles in parallel lines? Let me draw these two lines again, A and B. What if we go and draw a line through those two lines? This line is called the transversal. All right, but you don't need to memorize this word. So we see there are a lot of angles being made here, actually 8 in total. And the first thing you should notice is you should see how these two angles here are vertical angles. Along with these two angles, they're all vertical angles. And so are these two angles and these two angles. All right, so if I were to label these angles, let me see here. So this would be angle A. So angles A's vertical angle would be on that side. Then we have angle B, angle C, and angle D. Another thing you should notice is you just say, hey, angle A looks like it's the same magnitude as angle C. And that's right, because both of these parallel lines are going in the same direction. So that means they're going to make the same angle with the transversal. So actually, angle A equals angle C. So then we can write angle C as angle A as well. And in the same mindset, angle B is equal to angle D here. So we can label these as angle B. So when we have two parallel lines and transversal going through them, we have these four congruent angles, and we have these four congruent angles. All right? So you guys should remember that when we have parallel lines, we have two groups of congruent angles. So one of the groups is made of angle A, and the other group is made of angle B. And another thing you should notice is that angle A is supplementary to angle B. As you can see here, they make a straight angle. So that means every single angle in group A is supplementary to every single angle in group B. So for example, let me clear this up first. If we have another example here, this angle A is supplementary to any of the other large angles in this diagram. So it's supplementary to this angle, it's supplementary to this angle, and it's supplementary to this angle. All right? So to show you all the congruent angles here, what I like to do is I like to memorize, hey, all the small angles here are congruent, and all the big angles are congruent as well. All right, so when we have parallel lines and a transversal going through them, we have two groups of congruent angles with four angles in each of them. So 1, 2, 3, 4 congruent angles, and 1, 2, 3, 4. All right, and then the last thing you should remember is that all the angles in one group are supplementary to the angles in the other group. All right, so you actually don't need to memorize the placements of these angles. As long as you draw a diagram that's well drawn like this, then you can see clearly which ones are the small ones and which ones are the big ones. All right. So let's do these two problems here. So once you get the answer, please chat that to me. Right, how about one more minute for these problems? Because there's one more thing I would like to get through. And we're running a little low on time here. Okay, so if you haven't finished the second problem yet, you can keep working on that if you've already done the first one, because now I'm going to explain the first problem here. So in the diagram, line A is parallel to line B. Find the measures of angle Y if the angle X is 37 degrees. So first of all, this diagram is very badly drawn, right? It looks like X and Y are the same angle. So let's draw this line better. Let's draw this diagram a little better here. So let's make the transversal more extreme, right? So this means this angle is X and this angle is Y. So clearly, once we've drawn a better diagram, we can see that X and Y are opposing pairs. They're supplementary because X is one of the smaller angles and Y is one of the bigger angles. So this means X is supplementary to Y. So that means angle Y is just 180 minus 37, which is 143. Okay. Now for the second problem, it's a little better drawn. So in the second problem, line J is parallel to line K. Find X. So as you can see here, X is one of the smaller angles, and X plus 30 is one of the bigger angles. So this means that X and X plus 30 are supplementary. So when we add X and X plus 30 together, we should get 180 degrees. So 2X plus 30 equals 180. Now we use SADMAP to solve for X. 2X equals 150. If we divide by 2, we get X equals 75. All right, any questions about these? So the trick here was to find out which angles are big and which angles are small, okay? So now for these problems. So first, skip this problem here. Let's skip the first one. And I would like you guys just to focus on this challenge problem here with the chicken crossing the road. So once you get an answer, please chat your answer to me. But I know this is a challenge problem, so if you can't do it, that's totally fine. Since this is a challenge problem, I don't expect you guys to be able to work this out, but give it some thought. At least try to work out some kind of solution, and then I'll go over the solution in 1 more minute. Okay, I'm going to go over this problem now. So the chicken, it goes in a path A and B, A to B, that makes an angle of 22 degrees as shown. And then it makes a 71-degree turn and goes back to the other side of the road. So what's that angle X? So this is actually a very common type of problem that you're going to see a lot in the future. Okay, this is called a hinge problem. Okay, so how do we solve this problem? The trick here is to draw an extra parallel line going through B. So what does this parallel line do? If we look at this parallel line, there's a transversal here and the angle X right here. So that means the angle X is also this angle, right? Because these two lines are parallel, which means that these two angles X, they're both the small angles, so they must be congruent. And the same thing with the 22 up there. This angle here is also 22 degrees, right? Because for these two parallel lines, we have a transversal, and both of those angles are the small angles. So that angle is 22. As we can see here, x and 22 combined will make 71. So x plus 22 makes 71. Subtracting 22 equals x equals 49. All right. So the trick in this question was to draw out that extra parallel line through the middle, and then you can use everything you know about parallel lines and the angles to figure out how you would do this problem. Okay? So finally, angles in polygons. So we know what polygons are. Polygons are basically shapes. And the simplest polygon there is a triangle. So what is the sum of all the angles in a triangle? I think a lot of you already know this and memorized this. 180 degrees. Yeah. If we add up all the angles in a triangle, it equals 180 degrees. Now, what about a four-sided polygon with a quadrilateral, like a rhombus or square?
360.
Well, a lot of you guys know, oh, it's 360, but why is it 360? If we draw a line through here, we make one triangle and two triangles. Each of these triangles have 180 degrees. So since we have two triangles here, we have 2 times 180, 360 degrees. What if we went farther with a five-sided shape, a pentagon? What's the sum of the angles in this shape? Let's draw triangles again. Now I've got 3 triangles, right? And each of these triangles will have 180 degrees. So the sum of these angles is 3 times 180, 540. So for a triangle, I multiplied 180 times 1. For a square, 180 times 2. And for a pentagon, 180 times 3. So what's the pattern here? For a polygon with n sides, we do n minus 2, and then we multiply that by 180, right? For a triangle, we had 3 sides. 3 minus 2 is 1. For a quadrilateral, we had 4 sides. 4 minus 2 is 2. And for a pentagon, we had 5 sides. 5 minus 2 is 3. So basically, this formula, 180 times n minus 2 in parentheses, this gives us the sum of the angles in a polygon with n sides. Okay, so I'll give you guys a moment to write this formula down.
Wait, I have a question.
Yeah, what's your question?
So, but if you like do 2 lines in a quadrilateral, that's actually like 4, that'll become like 4 triangles.
Yeah.
And then people will think it'll be more.
Well, if we draw 4 triangles here, then we have extra angles in the middle that are not going to contribute to the angles in the quadrilateral. Since I've only drawn 2 triangles here, all the angles in these triangles are going to add up to the angles in the quadrilateral. Okay, so I've just drawn these triangles really carefully so that this will work. So that the angles will only be able to add up to the quadrilateral, and they're not going to be like somewhere in between adding up like that. Okay, so let's go through these last questions here, and then we're going to get to the quizzes. So let's just do the first problem. All right, so I think that must be enough just to get you guys experienced with how to use this formula. Okay. If I don't reply to yours, you should be okay. So this one shouldn't be that much work. You just need to plug in the values into the formula. All right. So I'll give you guys one more minute on this one. All Alright, I'm going to go over this problem here. So what's the sum of the angles in any 7-sided shape? Well, if we use the formula, the sum of the angles given by 180 times n minus 2 in parentheses, n is going to be the amount of sides the shape has, which is 7. So it's 180 times 7 minus 2, or 180 times 5. So this is 900 degrees. Alright, any questions? So you just have to know how to use this formula when you're given amount of sides. Alright.
I have one
So,
question.
one question? Yeah, what's your question?
So, like, I came here like a little bit late. So, what did you guys talk about at the beginning of class?
So we were just talking about angles and how they work. You can always go over the lesson on YouTube later. So I'm going to upload the video there. So you can go check that out later. All right?
Okay.
So it's quizzes time. So let me share my screen here. All right. All right. Pre-algebra angles. Let's get ready.
Can you do the link?
Yep, I'll do the link.
Thanks.
So the code is 135913. Let me try to get out the code here. Alright, so here is a direct link to join the quizzes. It's in the chat. If you click on that, you should get in immediately. Or you can go to joinmyquiz.com, and the code is Alright, so just like with all the quizzes we're doing, no calculator allowed for this one. We want to keep it fair. So yeah. What's that? Let me turn on my computer sound. You guys can hear the music later. All right, so normally we're gonna have 26 people, so I'm gonna wait one more minute. Oh, 27 this time. 28, wow. It's a new record. Okay, how about 10 more seconds? Okay, let's get started. Remember, no calculator, and have fun, guys. Here it goes. I'm gonna get you. Second place, Ryan. Third place, you. Actually, third place, a squared plus b squared equals c squared. Fourth place, you. Fifth place, jx. Fifth place, Lily. Lily now in third place. Richard is currently number 7, but has no incorrect answers yet. Alright, so current placings are: first place, I'm gonna get you. Second place, Ryan. Third place, Lily. Fourth place, JX. Fifth place, a squared plus b squared equals c squared. So if you finished, and you don't want to wait here anymore, you can leave, and I'll post the final standings, both in the chat and in my email later on, so you can check the final standings later. So if you finish the quizzes and you want to leave now, go ahead, feel free to do so. Jake currently with no incorrect answer, climbing up the ranking. Current standings are: first place, I'm gonna get you. Second place, Ryan. Third place, I'm watching. Fourth place, Andrew. Fifth place, Jake. So again, if you finish the quizzes and you don't want to stay here anymore, you can leave. And I'm going to post the final standings in the chat later on, and also in my email. chat so you can see the top 5 over there. All right. Thank you guys for coming to class today, and I hope you enjoyed. And I'll see you guys next time.
Bye.
See ya. Bye.
Bye.
Goodbye.